Hi, our names are Selina Jiang and Andy Jiang. Today we will be introducing you to our AI project. Our project is simply based on endangered animals and their closest living relatives. For example, pandas are endangered and bears are their closest living relative.
The problem we are trying to solve with AI is to try and find the most similar animals together, because many animals are hunted for the skin or hide and even just horns and tusks. We all know that many zoos are caring and taking in many animals, but unfortunately many zoos are packed over limits.
Our topic is helping zoos to save space and maybe even place endangered animals with their closest living relatives, because animals that are close relatives will commonly have the same behavior and die. Like for example, orangutans and monkeys both climb and have long limbs.
Part of the problem we have solved is that people will be able to store animals in classes and relatives. The social impact on this is that when animals are together, it will benefit children's education like science and biology, because if you are able to know which animals go together, you might invent something new.
We have been using Scratch and math and machine learning to code and put together little pieces of this project. We collected photos of pandas, bears, rhinos, and so on, and we often trained the AI regularly against each other and saw which one was more accurate and then improved it some more.
We encountered many problems, like for example the researching of the Scratch projects, or when the model says the confidence is too low.
The strengths are that when the project is completely finished, then it will look great and people will understand what the endangered species closest relative is. Well, some weaknesses about our project is that we could add more pictures of the same animal in different poses, and we could also even add more animals.
Our project is important because many of these animals are on the brink of extinction and it might be too late to clone them. But if that happens, we could just simply clone their closest relatives.
We have used AI to see the closest relative for the endangered animal species. Thank you. So my AI project is pretty simple, but so to activate my project, you're going to press the green flag, and then if you want to change the animal or the picture, right, you're going to press space, and then it's going to come up as a caption that says, right now it says, this looks like a bear. It is not endangered. Its closest living relative is a panda, and then my confidence. So that will go the same for every animal. If I keep on pressing space, it's going to change up as different animals. Sometimes it will repeat itself, but so for every single one of my codes, they're different, because you wouldn't want a panda, like the panda caption, under a bear. So you would have to change all of the subtitles and like the text. So every single the confidence, the decimal, like the higher the confidence is, the more sure that it will get the photo picture right.
So we trained the machine by going into machine learning, and if I click on train, then all these pictures will come up. So we put each different animal pictures in different boxes. So then once the AI knows this is a giant panda, AI can just scan all the images to see like this is a giant panda and this is a bear. So then in Scratch, so it can scan the animal in the pictures, and then it can tell you what type of animal it is, and if it's endangered or if it's not, and the closest relative.
Hello everyone, our names are Justin Wayne and Jonathan Day. We are 11 and 10, and today we will be making a project called Math Project. So in our project, we created a system that can recognize a face mask if worn properly, if it is not worn properly, and if the person doesn't have one. Artificial intelligence can help with this and can be used at the front of stores instead of people there.
We used Teachable Machine to craft this project because we found it was the easiest because of its built-in image recognition using neural networks and its web control. In the data collection process, we collected 600 images for each class and used the webcam for the images. For the training, we used 50 epochs, a batch size of 16 and a learning rate of 0.001. Our testing went well, it almost got every single one correct.
Additionally, we have made an animation in Scratch that when a person comes to a shop, the sensor will check and predict if the person is wearing it properly, if it is not worn properly, and if the person doesn't have one. It also has a function that allows it to switch costumes by hitting the space button.
Machine learning for kids didn't work in our Scratch project, so we changed it to Teachable Machine because we could easily switch in and out of websites and it could be linked by the export models upload in my project. We used a different shirt for 1 out of 3 and it would not work, so we looked back and discovered it was biased. Therefore, we did the same for exactly else. That one change worked.
Our solution will gradually reduce COVID-19 in shop, and it can be cheap and easily installed. It can also be used for other purposes too. And we can also add a monitor to track fees in the shop and make sure items don't get stolen. But the weakness of this project is that it needs images of many different people for recognition to work correctly. Masks are very important in this time of life. Our project will help, but it will not finish the issue. We also need your help to end COVID-19 once and for all. Thank you.
So with Teachable Machine, you have to go to webcam and record some, because now the thing is our faces are recording, so we can't really use the webcam. And also if you upload, then you can import images here. So you at least have to have 2 classes, and for at least you at least have to have 5 image samples for each, otherwise it won't train. Yes, so we have 1, 2, 3, 4, 5 classes. And for each class we did 750 image samples.
We need so many photos because if it were just one, it would only recognize the exact same picture.
The difference between training photos and testing photos would be, for testing, it really depends. Because if your data collection is not correct, then your testing will not be correct either, because it's only got a few samples. If this blue t-shirt was only in here, then it would be biased, because if I was wearing a blue t-shirt, then all of this will be in here because it's the only one. So we figured that out, and we had to add a blue t-shirt for every single one. Then it got better.
If I put in too many pictures of a boy and no pictures of a girl, but it will only recognize boys.
A sample size would be a sample size. So in the advanced, an epoch would mean how many times the program is run through for every single one. So for this, it would be 750 multiplied by 5 and then times 50, which would be a lot. It means the testing would be much better than if you only use one epoch. For the learning rate, it learns because if you had this number at a really high number, such as 2000, then the learning rate would be really fast, but your test results wouldn't be that good. 0.001 would be a good learning rate, because that way it wouldn't go too fast, and the testing would be good.
Hello, my name is Mia and I will be explaining my AI project, Sorting Waste. So basically, my program uses Teachable Machine to recognize different types of waste and put them in different bins. So people can just put their rubbish into one universal bin and not have to worry about sorting it themselves. So if a robot did all of this, people would just have more incentive to recycle because it would be really easy. Just dump your rubbish in a bin and the robot will do the sorting for you. So my teachable machine model can identify different types of waste and whether or not they're recyclable. It then decides which category the waste goes to and automatically sorts it, making it much easier for people to sort rubbish. I use the program Teachable Machine, which uses neural networks in the background for image classification. So first, I collected data in several classes of rubbish: organic waste, food packets, plastic bags, plastic bottles, and plastic cardboard and plastic and paper cups. So then I uploaded them onto my teachable machine and trained and tested my model. So a difficulty I encountered was catering for all types of rubbish. For example, the term organic waste describes a really wide variety of waste, from banana peels to apple cores to leaves, and none of them look even remotely alike. So I just used images that were relatively similar to each other, but also had a lot of different types of rubbish in one image. But even so, a weakness would be that my overall model wasn't very diverse and would have lower accuracy levels, picking up anomalies or things that aren't in my images, like colored plastic bags or patterned cups, etc. A strength of my program is that it's relatively simple yet very accurate, and there's a pretty low chance of something going wrong. And even if something did go wrong, it would still be better than not having a program at all. So overall, things like plastic pollution and sorting wastes wrongly are major issues around the world, and my AI program, which automatically sorts rubbish, could really help. Thank you.
So can you tell me about what made you decide to do sort rubbish?
So basically, this is kind of about me too. Whenever I'm sorting rubbish, I just find trouble because I have to look at the images on the bin and then decide which bin I put the rubbish in. So I decided that I was going to make it a lot easier for everybody, and it's also better for the environment as well.
And have you thought about what kind of hardware you would use to actually physically sort the machine?
I'm thinking it would kind of be a large bin with one hole in it, and you put your rubbish in the hole, and there's a kind of sorter that flips it into whatever bin it may be.
My name is Mia Kai and my project is sorting rubbish. Not many people are actually bothered to recycle because it's extremely difficult. For example, I had a coffee cup in my hand and you had to separate the lid from the cup and then put the cup and the non-recyclable and the lid and the recyclable, and it was extremely confusing. So I thought I'd just build a AI program to do that for you, which means more people would have a bigger incentive to recycle because it would be really easy and it'd solve the problem to some extent. So as you can see, I've used Teachable Machine and I have 6 classes: organic waste, food packages, plastic bottle, cardboard, plastic bag, and paper cup. So as you can see, I have 10 image samples in each class. A problem with this is actually that they look pretty similar, which means that in the future an improvement could be made. We would need a lot more image samples that were different to make sure that the machine could pick up more things. And although it is quite similar with each other, it is actually pretty accurate. I'll just give some examples. I used this testing image, and as you can see, it's actually not in my training data. So it's very accurate. It's 100%. And if I've collected several images and each one of them is not in my training data, and each one of them is very accurate. And as you can see, even this is a plastic bag, but it's actually a different shade of color to the things that I've had in my training, which means this is relatively flexible as well. So we'll just test with 2 more examples. Yep, as you can see, very accurate and not in my training data. So that's the benefit of this program. It's relatively simple and it also has a very high accuracy as well. I believe it'll be very useful because right now one of the biggest problems in the world is things like plastic pollution or landfill contaminating water and things like that. In the end, the robot will use like a scanner to find image recognition and kind of like sort the rubbish into separate bins. So that would make it easier to sort rubbish.
The state of New South Wales, Australia has the return and earn system for recycling bottles and other containers. While it's good, there are problems. Imagine this situation. It is a regular Sunday morning at an average return and earn station. There's an overwhelming horde of people trying to put the bottles or the containers into the machine and get the money. But some of these bottles aren't accepted. So people at the machine try again and again, which frustrates the people behind them. Some people give up waiting and put the bottles in the trash. These bottles pollute the environment.
Our system enables everyone to check whether their containers are eligible or not. This is done before they go to the collection point whilst they are at home. This makes recycling much easier, saves people lots of time, and encourages more people to do recycling regularly and reduces trouble to our community. Most importantly,
less rubbish everywhere and a more cleaner environment with better sustainability and less animals dying.
We have made prototypes in both Google's Teachable Machine and Machine Learning for Kids.
Google's Teachable Machine taught us how machine learning worked, as well as its capabilities and limitations. We discovered that Teachable Machine uses neural networks, which is a part of supervised learning. Teachable Machine allows users to teach an AI to recognize and sort objects. Something else you can do is look under the hood, seeing what the AI undergoes during training.
Neural networks are similar to what happens in the human brain because it's based on it. Basically, you have a bunch of neurons. They take in an input and then they have an output. And then that output gets fed into other neurons and then the process continues.
To train the system, we took over 100 images of containers we found at home from different categories. We also added some free images from the internet of additional containers from categories in which we did not have enough samples. This data collection has taken a lot of time. We kept the images of our bottles consistent with a white background, as keeping everything consistent means the AI will not inaccurately classify a bottle due to the background. In Google's Teachable Machine, we set the settings to 50 epochs with loading rate of 0.001 and a batch size of 16. To test the system, we used test images similar to the ones that we use for training, except the AI had never seen these images before. Both Google's Teachable Machine and Machine Learning for Kids returned similar positive results.
However, we are able to figure out some issues as we continue to develop our system.
Our system makes recycling easier and encourages more people to recycle regularly. As a result, there will be less pollution of the environment, and this will be good not only for plants and animals, but also for your health.
the major problem with return and earn is that the container eligibility rule is too strict and can be confusing for some people. For example, plastic bottles with dents are not eligible. Because of this, a relatively large number of containers that people bring to the collection point cannot be accepted. Some people go to the collection points carrying large amounts of containers just to find out that most of their containers cannot be accepted. This causes inconvenience to people and discourages recycling. Our system enables everyone to check whether their containers are eligible or not. This is done before they go to the collection point whilst they are at home.
We have experimented with several prototypes, and we will present one of them to you today.
Hello, this is our teachable machine model. It is using neural networks, and I believe it's pretty accurate.
There's 7 classes of containers. Some are returnable, some aren't returnable. In our teachable machine model, you can take pictures with the webcam or already taken pictures. First, we'll demonstrate how to use this with already taken pictures. So this image is a good plastic bottle that you can return, and here it came up as 97% plastic good return. This test image wasn't in our training set,
So the system is good. So if you want to use a webcam, you press the webcam feature. It's highly recommended to have it on something blank and white so that it doesn't accidentally sense any of the other things that can distract the AI.
As you can see here, it identified this as a plastic good return bottle with 100% accuracy, and it is correct. Yes, this is a plastic bottle that's empty and can be returned. This is really good because it's 100%, no doubt, it's a cardboard returnable type, and this is true, it's a tissue box.
Our Scratch projects works like this. So this is going to be the thing that classifies it. If it has a confidence of lower than 80%, then it says that it's not confident enough. If it is confident enough, then if it classifies as a can, then just print it is a can, etc. And that's basically how it works.
It's really difficult to train since we had only a limited number of data, and we probably improved this by increasing the amount of data as well as increasing the number of classes.
One example of limitation of our machine learning program is that it is not yet portable to mobile. This is one of the most pressing issues as mobile devices are already extremely popular and used by a lot of people.
Some positives for the project would be less plastic things, less animals dying, less rubbish everywhere, and a more cleaner environment with better sustainability.